Nepal, a landlocked nation nestled in the Himalayas, boasts a unique geographical advantage: abundant water resources. These resources hold immense potential for hydropower generation, offering a sustainable solution to Nepal's energy needs and a pathway to economic growth. Hydropower harnesses the energy of flowing water to generate electricity, providing a clean and renewable alternative to fossil fuels. By tapping into its vast hydropower potential, Nepal can illuminate homes, power industries, and create a brighter future for its citizens. Hydropower plants operate on a simple principle. Water flowing from a higher elevation to a lower elevation possesses kinetic energy that can be captured and converted into electricity. This process begins with the construction of a dam, which creates a reservoir of water at an elevated level. The water is then channeled through turbines, causing them to rotate. These turbines are connected to generators which produce electricity as they spin. The electricity generated is then transmitted through power lines to homes, businesses, and communities. Hydropower offers numerous benefits over traditional energy sources. First and foremost, it is a clean energy source that does not produce greenhouse gas emissions or air pollutants. This makes it an environmentally friendly alternative to fossil fuels, which contribute to climate change and air pollution. Second, hydropower is a renewable energy source, meaning it can be replenished naturally over time. As long as the water cycle continues, hydropower plants can generate electricity without depleting natural resources. Third, hydropower plants have long lifespans, providing a reliable source of energy for decades to come. Nepal's hydropower potential is estimated to be over 83,000 megawatts, yet only a small fraction of this potential has been tapped. This presents a significant opportunity for the country to develop its hydropower resources and meet its growing energy demands. By investing in hydropower, Nepal can reduce its reliance on imported fossil fuels, create jobs, and stimulate economic growth. Moreover, hydropower development can bring electricity to remote areas of the country, improving living standards and promoting social development. Choosing the right location is crucial for a successful hydropower project. The ideal site should maximize energy generation while minimizing environmental impact and costs. In Nepal, site selection requires careful consideration of key aspects due to rugged terrain and sensitive ecosystems. Availability of water resources is a primary factor. The site should have a consistent flow of water throughout the year. This involves analyzing historical rainfall data and river flow patterns. Identifying locations with perennial water sources is essential in Nepal. The topography determines the type and size of the hydropower plant. Steep slopes are favorable for high-head projects. Gentler slopes suit low-head projects. Nepal's diverse topography offers various options for hydropower projects. Accessibility impacts construction costs and logistics. Sites easily accessible by road are more favorable. Environmental considerations are paramount. Choose a location that minimizes impact on ecosystems and communities. Before embarking on a hydropower project, it is essential to conduct a comprehensive feasibility study to assess its technical, economic, environmental, and social viability. This study serves as a roadmap, providing crucial insights and informing critical decisions throughout the project lifecycle. A well-executed feasibility study significantly increases the likelihood of project success. The technical feasibility assessment focuses on the engineering aspects of the project, evaluating the site's suitability for hydropower generation. This involves analyzing hydrological data, geological conditions, and topographical surveys to determine the optimal design and capacity of the plant. Factors such as dam height, turbine type, and power transmission infrastructure are carefully considered to ensure the project's technical viability. The economic feasibility study examines the financial viability of the project, considering factors such as construction costs, operating expenses, electricity tariffs, and potential revenue streams. A detailed cost-benefit analysis is conducted to determine the project's profitability and return on investment. Sensitivity analyses are also performed to assess the impact of potential risks and uncertainties on the project's financial performance. Environmental and social impact assessments are crucial components of the feasibility study, evaluating the potential environmental and social consequences of the project. These assessments identify potential risks to biodiversity, water quality, air quality, and local communities. Mitigation measures are proposed to minimize negative impacts and enhance the project's sustainability. Stakeholder engagement is an integral part of the feasibility study, involving consultations with local communities, government agencies, NGOs, and other interested parties. This inclusive approach ensures that local concerns, perspectives, and traditional knowledge are considered in the project's design and implementation. Open and transparent communication throughout the process helps build trust and fosters a sense of ownership among stakeholders. The design and engineering phase of a hydropower project involves translating the findings of the feasibility study into detailed blueprints and technical specifications. This phase requires expertise in various disciplines, including hydraulic engineering, civil engineering, electrical engineering, and environmental science. The goal is to create an efficient, reliable, and environmentally responsible hydropower plant. Hydraulic engineers play a crucial role in designing the water conveyance system, which includes the dam, intake structure, penstock, and powerhouse. They determine the optimal size and shape of these components to ensure efficient water flow and energy generation. They also consider factors such as sediment transport, fish passage, and water quality. Civil engineers are responsible for designing the structural components of the hydropower plant, including the dam, powerhouse, and other supporting infrastructure. They ensure that these structures are strong enough to withstand the forces of water pressure, earthquakes, and other potential hazards. They also consider factors such as soil conditions, seismic activity, and the availability of construction materials. Electrical engineers focus on designing the electrical systems of the hydropower plant, including the generators, transformers, switchyard, and transmission lines. They determine the optimal voltage levels, power output, and grid connection points. They also consider factors such as power quality, grid stability, and the integration of renewable energy sources. Environmental engineers and scientists play a critical role in minimizing the environmental impact of the hydropower plant. They design mitigation measures to address potential impacts on water quality, fish habitat, and biodiversity. They also monitor the plant's environmental performance during construction and operation to ensure compliance with environmental regulations.